Welcome to Class TV. I am myself Ali Tosin. Now we are taking part one of this great topic, equilibrium of forces. Under this topic, we'll be talking about the concept of moment. We talk about couple. We talk about tug. We'll also be able to talk about the concept of measuring masses using meter rule, and we'll be taking enough calculations. We'll talk about the concept of equilibrium of rigid bodies that are parallel, also the one of non-parallel forces. We'll also talk about equilibrium of bodies, of coplanar bodies, coplanar forces. All these are what we'll be discussing at the course of our topic. Now, let's start. Now, let me start the example. Looking at this ruler I'm holding, we can say that this ruler is not balanced. Now it is balanced. Now, two forces are acting on it. We have a force this side and also another force at this end. And we can say that what? For this ruler to be balanced, then it is at what? Equilibrium. Then we say that what? It is what? On equilibrium. Now, for an object to be on equilibrium, the sum of clockwise moments, see my hand, the sum of clockwise moments must be equal to the sum of what? Anti-clockwise moments. The sum of clockwise moments must be equal to the sum of what? Anti-clockwise moments. That is when we say that what? The body is at equilibrium. Now, what is moment? Moment refers to the turning effect of forces about a point or axis. Turning effect of forces about a point or what? Or axis. There is a turning effect here. You see that? So around across its axis, we say it is what? It is moment. Now, example of moment: a bottle top. If you want to open our bottle top, what do? We roll it. It rotates. It rotates, and that's what shows an example of what? Moment. Right? And when we want to close the top of the bottle again, we rotate it anti-clockwise. Now, also opening of a door. When we want to open our door, we either push it forward, that's pull it, or push. Also, rotation of wheels of vehicles. The wheels of a vehicle does what? Rotates, right? Around its axis. So we say those are examples of what? Of moments. Now, moment of forces. We said the moment of forces refers to what? A point. No, moment of forces about a point refers to the product of the force and the what? The perpendicular distance. And sorry, it should be and the what? Perpendicular distance of its line of action from the point. Now, what are we saying there? If you have a rod here, right? Having a rod there, we can say that what? And if this is the center, let's take this as the what? At the center of the rod, right? Let's take that as the center of the rod. Okay, and this as the end. This is center. Let's call it O. And a force is acting downward here, W, right? It is a force which could be referred to as F. Now, what are we saying? The distance between this place and this point, let's call this point P, we denoted by what? D, right? Distance between this center and where the mass, the force is what? Is hung, then is what refers to as what? Our D. And this downward force is F. Like we said that it is the what? We said moment of force at a point is the product of the force and its perpendicular distance. We see that this distance is perpendicular to the force. Is perpendicular to the force. So with this now, we can say that what? Our moment of force is equal to what? F times what? D. F times D. That is what? Force times what? The perpendicular distance. Times the perpendicular what? Distance. Now, so which means you can say that what? Force is measured in Newton and distance is measured in what? Meters. So the unit for calculating what? Moment is what? Is Newton per meter. Newton per meter. So moment is force times distance. Distance are measured in what? Newton per meters. Now, let's look at this. We also have, if you have a rod here, okay, like I said, okay, let it be a double line. And we said, like I said, this is what the center O. And this, instead of us having the force hung vertically downward like this, it is hung this way. The force was hung this way. Which means, let's call this the force F. Now, let's assume this continues. Then we can say that if we join this line here, becomes our P. If you join this together, this forms a right angle here. And this is our what? Theta. Now, with this now, we can say that what? With this now, we can say that our moment is equal to force times OP. Just like this is the OP here too. Force times what? Line OP, which is the perpendicular distance. Now, note that our OP here, using sine's rule, this part becomes the what? The hypotenuse. And this becomes the what? The opposite from SOHCAHTOA. Then we can say that this is our line OP. We can say that on this, we can say that we can have something like sine theta is equal to opposite is OP over this is what? Let's call this the hypotenuse. Let's call this H, which means that over H, which is hypotenuse. So that means our line OP will be given as what? H sine theta. Yes, we given as H sine what? H sine theta. That's it. H sine theta. So with that, now we can say that this OP now can be written as H sine what? Theta. So we can say moment is what? F equals to F times what? This A, that is distance here, times what? Sine theta. That is what? Another formula for finding moment. That's if you are giving your what? The inclined angle. Okay, we continue on that one next to meet. I do myself, Alewi Tosin. Thank you.